Got some liquid nitrogen flowing here, Matt.
Yeah, we do.
All right, welcome back to the morning show. It is Wednesday. It's coming up on 6:49. That means one thing. Matt's selling wise guy, physics genius is in the house to blow something up. It's been a while.
It's been a while, yeah. And so a couple of weeks ago, you had the insect guys in here,
yes,
right?
we did. Right?
That was cool.
That was pretty cool. Although the girls didn't really like the creepy collar things.
Really? I like those.
Yeah, I do too.
As far as you know.
So
I thought we would come back. We haven't done this for a while, and I really like playing with liquid nitrogen, and it's kind of fun when I bring it in here. Mm-hmm. And just for the kids watching who study solids and liquids and gases, the states of matter, this is something that we like to do once in a while. And so what I want to focus on today is the difference between a liquid and a gas.
Okay.
And so the big difference is that, generally speaking, if you have some material like water, if you wanted it to be a gas, it boils, it's hot.
Sure.
Liquid is kind of colder.
All right, you freeze it.
Okay, so the gas is generally warmer than the liquid. It doesn't always have to be the case. You can always cook things up so they're different, but in this case it's certainly true too. And what I have here is I have started with a gas, which is this air, nitrogen, the stuff we breathe in, and we made it very, very cold, and so it's a liquid. And so inside of this little container is this liquid nitrogen, or liquid air, and it's about 320 degrees below zero. So it's very cold, but it has to be because the boiling point of the stuff is just so low. Now the interesting thing about it today isn't that it's so cold, it's that we want to demonstrate the difference in size basically between a gas and a liquid.
Okay.
And it turns out, so in a liquid the molecules are as close together as they can get. They can't get any more. They're basically touching. In a gas they can go everywhere. They're sort of far apart. They're about 1,000 times greater volume than a liquid is for normal pressures like we have here on the Earth. Okay, and so when I pour this stuff out, hope you can see that. You see little tiny droplets,
right,
but they evaporate very quickly. They boil, and that's because the stuff is so cold. When we put this on normal temperature stuff like we have in this room, it's like pouring water on a red hot plate. It just evaporates instantly.
Okay.
So we can use that to show the difference between liquids and gases because it's very easy to turn this stuff into a gas.
Okay.
So the first thing I'm going to do before we blow up this bottle is just pour a little bit into this balloon, and I'm just putting a couple of drops. I'm going to sort of pinch it off, and you'll see that the balloon starts to get bigger, right? I only poured in maybe a tablespoon or a teaspoon of that stuff in there, and you can see that as the stuff turns from a liquid into a gas, as it boils, it just takes up a lot of room.
Getting bigger and bigger.
Okay? And so what I'm going to do, is we're going to do a little bit of an explosion, and I've never done this before in a studio on a table.
Beautiful. We're glad to be the guinea pig.
And we may never do it again. It depends on if we have to call the ambulance.
But for Russ Hamilton,
we do have the doctors in the house, so maybe
we do have a doctor.
And so what I'm going to do is I'm going to start with this milk jug, which has been squished, so it doesn't have much volume in it. Okay. I'm going to pour some liquid nitrogen into this thing.
All right.
Then I'm just going to screw the lid on, and it'll be just like a balloon, except it'll happen a little faster. It's going to blow this thing up, and eventually it can't get any bigger, and it might just pop.
Has to go somewhere,
It just might just pop. Okay. We'll hope for the best. And we should probably run away before this happens.
All right, will you just tell me when to hightail it?
I will do that.
Do you need me to put the lid on it, or?
I'm going to put it in there.
Let's aim the cap away from the cameras.
Okay, now we're going to... Wow.
Okay.
Yeah, that was pretty good. Now, normally, when I want to blow something up and make a great... Hey, that's pretty cool. Look at that. We got a great big hole in it. Okay. And so what I'm going to do when we come back is I have this sort of a cannon contraption that I've made. And it's just basically a really strong sewer pipe, which is capped off on the bottom, if you can show this thing. Yeah. And what I'm going to do is I'm going to put some liquid nitrogen in a soda bottle. Okay. And the same thing's going to happen. I'm going to put it in the bottom, but then I'm going to put just this ball over top. So it's going to work just like a gun. You're going to have very rapidly expanding gases. It's going to launch this ball, and we're going to see how far we can make the ball go. Maybe across the street.
Go out for a pass. Yeah. Fly pattern. See if I can catch that.
Yeah.
Well, we put a hole through this baby.
Yeah, sure did.
All right, Matt. Good job.
Do we have a second?
No, we have about 30.
Okay, because then I can talk about what we're going to do next time. Okay, just in case I don't have time in the next segment.
All right.
Okay, so this brings up this pipe, actually. Right. See how that makes that noise?
Sure.
Okay. So we're going to start talking about resonance and sound a little bit, and we're going to work our way up to breaking glasses with sound, things like that. And
like opera singers?
Yeah, except you're going to sing.
No, oh my gosh, that's going to break TVs.
That's right.
All right, if you want to see a replay of Matt's blowing up this milk jug, go to our website, IllinoisHomepage.net. Look under the morning show and look under the Wise Guy.